Hey everybody, I'm going to do the Circuit Sudoku Challenge worksheet. If you have that printed out, you can get it now. If you're not going to print it, you're just going to work the problems on notebook paper. What you're going to need is to draw these circuits here. This first page are some examples and I want to work those out for you. So if you need to sketch this out, pause the video and draw these two out. And then there are actually two more on the back side of this page that you want to draw out as well. And then you can come back and start the video from this point. Alright, so the first thing I want to show you, this is a series circuit. We know it's a series circuit because the battery here has these resistors connected head to tail. There's only one path through this circuit, so that's what a series circuit is. This circuit down here is called a parallel circuit because if you look at the battery and the arrangement of the resistors, there are branched configurations. So current could run through this loop here, current could run through this middle loop here, or current could run through this outside loop here. And the current actually splits up and has a choice. So when the resistors are side by side like this with branching points, that's a parallel configuration. Alright, so some of this information is labeled. I know that the total voltage of this battery is 12, so I'm going to fill that in there. I know that R1 is a resistance of 5 ohms. I know R2 is also 5 ohms, and I know R3 is 10 ohms. From here, you have to know the rules that were in that summary document I linked for you about how to add resistors. In series, resistors are simply added together. So the total resistance is R1 plus R2 plus R3. And if there were more resistors, you would just add those all together. So over here in this column, to get my total, I'm going to add 5 ohms plus 5 ohms plus 10 ohms. So you get 20 ohms as your total resistance. Now, we know our total voltage and we know our total resistance, so we can find total current. If I come back over here in my workspace and just do a quick Ohm's law problem, V equals IR, and then I get the handy dandy calculator, I can find out that the total current in the circuit is 0.6 amps. Now in a series circuit, you see how there's only one set of wires connecting these resistors, therefore the current can only flow in one direction and in one pathway. There are no branch points or options. The current can only flow through this one loop. So if the total current in this circuit is 0.6 amps, the rule for current in a series circuit is that the current is the same everywhere. So I know all of those resistors have 0.6 amps of current running through them. Now the last thing I have to figure out is the voltage drop across each one of these resistors. That's just going to be another V equals IR problem because I know the current and I know the resistance for each one of these three resistors. So I'm going to go over here to the workspace that's right beside R1. Let me focus this for us real quick. Okay, that's a little better. I know that V equals IR, so the current is 0.6 amps and the resistance is 5 ohms. And so then I get a voltage drop of 3 volts. Okay, so that's the voltage drop across R1. I can do the same thing for R2. V equals IR. The current is still 0.6 amps, and this is also a 5 ohm resistor, so I'm going to get the same 3 volt drop here for R2. And then the last resistor is a 10 ohm resistor, so I know the current running through there is also 0.6 amps, but a 10 ohm resistor, so I get a total voltage drop of 6 volts there. Okay. Now, if you take a look at what's happened with these voltage drops, my total voltage from the battery is 12 volts. And after after I leave the battery from this positive terminal, I'm going to drop 3 volts here. So 12 minus 3 is 9 volts. I'm going to drop 3 volts here. 9 minus 3 is 6 volts. And I'm going to drop 6 volts here. 6 minus 6 volts is 0 volts. You should end up at 0 volts at the end of a series circuit. So all 3 of these voltage drops will add up to the total voltage from the battery. And that's true for any series circuit. Now, the next thing I'm going to do is flip over to problem number 3 on the back, this one. This is a 120 volt battery. There's a resistor of 20 ohms here. This resistor is unknown, and then this resistor is 30 ohms. This is a 2 amp reading on an ammeter, which measures current. So I'm going to fill in the 120 volts here. My R1 is 20 ohms. My R3 is 30 ohms. And this is a series circuit, so if the ammeter for current is reading 2 amps, that means the current is 2 amps in every location because it's a series circuit. So now I've got a couple of rows where I know 2 of the 3 values, and I can figure out the third one. So for R1, I'm going to go over here and work. If I want to solve the voltage with Ohm's law, I've got 2 amps of current through a 20 ohm resistor. That's 40 volts. And then I can skip over here to R3. I have 2 amps of current, and that's a 30 ohm resistor. So that's a total voltage drop of 60 volts. Now remember what I told you in the first problem about these voltage drops adding up to the total. If I have 100 volts accounted for here, I need the rest of it to show up here. So 40 volts plus 20 volts plus 60 volts equals 120 volts. That's how I knew what went right there. Now I can solve for R2. I'm looking for its resistance. So a 20 volt drop with a current of 2 amps gives me an R value of, if I divide both sides by 2 amps, I'm going to get R equals 10 ohms. So the resistance here is 10. Now I need to get my total resistance. In series, I know that the total resistance is just the sum of all the individual resistor values, so I could get that by coming down this column. 20 plus 10 plus 30 is a total of 60 ohms. The other way you could get this problem is by working across the row, and you could use Ohm's law, V equals IR, to get a value of 60 ohms here. So that's how you work out the series problems. You can stop the video here for just a second. I'm going to flip back to the first page, and I'm going to work this set of problems that are parallel circuits next. Okay. So for a parallel circuit, the current's going to flow from the positive terminal of the battery through the circuit, but I mentioned to you earlier there's a branch point here, and there's a branch point here, and here. So some of the current is going to branch off at this point and travel through the 10 ohm resistor. Some of the current is going to continue on and travel through the middle path of the 5 ohm resistor, and some of the current will travel all the way to the last point and go through R1, which is a 5 ohm resistor. There's a famous saying, you've probably heard it, that says current takes the path of least resistance. So if that's a true statement, R1 and R2 represent the least resistance. More current should flow through these resistors than through this one. So let's work out the problem and see if that's true. R1 is a resistance value of 5, as is R2. R3 is a 10 ohm resistor. So I've got the same resistors that I did up here in the first example, they're just configured in a different way now. Also, the battery is a total of 12 volts. Alright, so with resistors in parallel, you have to add them in a different way. It's not like this in series. The way you add resistors in parallel is to do an inverse addition. 1 over R equals 1 over R1 plus 1 over R2 plus 1 over R3 for however many resistors you have. So I'm going to substitute in 1 over 10 plus 1 over 5 plus 1 over 5. Now, I know that a lot of you will just do this in your calculator. I choose to do it old school. I find a common denominator like you learned in 3rd grade. Add fractions with common denominators. 1 over 5 is the same as 2 over 10, just like this one. Okay? And so now 1 over 10 plus 2 over 10 plus 2 over 10 equals 5 over 10. But remember, 5 over 10 is 1 over R. So then you have to invert that. Just flip it upside down. If you flip the left side upside down, you've got to flip the right side upside down. So our total here is equal to 10 over 5, or 2 ohms. And I'm going to plug that in right here. Okay. Now I've got this row figured out. If I want to find the total current, I can take my 12 volts and my 2 ohm resistance, and I get a total current of 6 amps. That's going to go right there. Okay. Now, in a parallel circuit, the current is not the same throughout because we know current splits up. So the next thing I'm going to have to do is think about the voltage drop instead. With each one of these loops representing a closed pathway for the current, I know that if I have to end up at 0 volts over here and I start with 12 volts here, that has to happen in each one of these loops. Just like up here, all these voltage drops added up to 12 so that I ended up at 0 volts at the end of the loop. I need each individual loop here to add to 0 volts, or to drop to 0 volts. That's a better way to say it. So if that's the case, I know that in parallel circuits, the voltage drop is the same for every one of those loops. And now we're pretty much home free. I've got 2 of the 3 values from Ohm's law for each one. So I'm going to go over here and plug in the numbers for R1. I have 12 volts. I can solve for the current if it's a 5 ohm resistor. Handy dandy calculator. 12 divided by 5 is 2.4 amps. Okay. R2 is going to be the exact same math because it's the same exact values. So I'm going to also put 2.4 there. And now we could do R3, 12 volts times an I and a 10 ohm resistor. I is going to be 1.2 amps. Okay. Remember what I told you before we started this problem, that current takes the path of least resistance. So more current flows through the smaller resistance here, less current flows through the larger resistance here. If you're a really good proportional thinker, you can see why this works out. R1 and R2 are half the resistance of R3. So the current that flows through R1 and R2 is double the current that flows through R3. Alright, you can pause the video here, and I want you to try and solve the last parallel circuit on the back. I'm going to silently plug my values in here while you're working, and then you can start the video again when you're ready and check your answers with mine and see how you're doing on the parallel circuits. So good luck, and I'll talk to you soon. So there you go. That's the last example. Hopefully your answers match mine. Now you can begin working on the challenge problems that start right here below that last example. Thanks.